no evidence that a groundhog can predict the weather. In fact, Groundhog Day predicts the wrong outcome most of the time. You might as well just flip a coin.
So how do we know when winter ends?
Well, I'll give you a hint. It has to do with something blue, big, and you're standing right on it.
This blue floor?
I think he means the Earth.
Yep,
Well, how does the Earth tell us that?
that sounds like an investigation waiting to happen. I'm Dr. Jeff Whitaker, and today we're going to explore Earth's orbit and rotation. We'll learn that the Earth rotates on its axis every 24 hours and orbits around the Sun every 365.25 days. That its rotation causes observable patterns like night and day, and its orbit around the Sun causes some stars to be visible only in certain months. Welcome to Labracazam, where we make science make sense. So, what do you guys know about the Earth's movement?
Well, I know it orbits around the sun.
That's right. The Earth moves in two different ways. It rotates on its axis once a day, and it orbits the Sun once a year, like this model.
So Earth is always moving, both spinning on its own axis and also orbiting around the sun. But what is it about the way it moves that creates all those changes?
Great question, Zoe. Let's break it down. The Earth's rotation causes all kinds of patterns that we can see.
Like night and day.
Exactly. To demonstrate this, we're going to use this flashlight, which will represent sunlight. Here you go, Izzy. And this globe, which represents the Earth. I need the lights off. Bert?
Consider it done.
Awesome. Izzy, go ahead and shine the sunlight on the Earth. Zoe, you can rotate the Earth.
It looks like as the Earth rotates, Izzy's light is only hitting half of the globe.
That's right. Another pattern we can observe caused by Earth's rotation is the length of our shadows. Let's check it out.
My shadow always seems longer and in the afternoon than in the middle of the day.
That's true. Bert, would you like to help us demonstrate that?
No thanks. I'm afraid of my own shadow.
Okay, then we'll have to use this 3D printed model of Izzy.
Okay.
Zoe, turn on the sun.
The sun rises in the east, so we should start there.
It looks like when the sun rises, it's lower in the sky, which casts a larger shadow.
And as the Earth rotates, the sun appears higher in the sky, like at noon, and makes a shorter one.
Now, the sun doesn't really travel across the sky. It just looks that way because Earth is rotating.
Is that why it appears that stars move at night?
That's right. Stars appear to travel across the night sky, but it's really us that's rotating.
Is there any other evidence that's the Earth that's rotating?
Yes, there is, and I have the perfect tool to demonstrate. This is a model I made of a Foucault pendulum. It's an invention that helps us see that the Earth is rotating even though we don't feel or see it. Zoe, do the honors. Just pull back the weight and let go. Perfect. Then this pendulum is swinging forward and back each and every time in a straight line. Let's see what happens if I rotate the surface underneath it.
Still swinging in the same direction.
Exactly. And that's part of the evidence that scientists have that the Earth is rotating. Besides seeing it from space nowadays. By freely suspending the pendulum, French physicist Léon Foucault was able to demonstrate Earth's rotation. As the Earth rotates, the pendulum continues to swing in the same direction, providing evidence of the Earth's rotation. But can you two think of any patterns caused by Earth's orbit around the sun?
Is that why the night sky looks different throughout the year?
That's exactly why. It takes 365.25 days for the Earth to orbit around the sun. Since we can only see stars at night, we can only see stars in one direction. However, this view changes due to the Earth's orbit. That's why we see different constellations at different times of year. So now we know that those changes occur because of Earth's orbit around the sun.
But for a long time, people thought it was the sun that orbited around the Earth.
That's right. That was called the geocentric model. It was accepted as fact for over 1,000 years. It made sense to ancient scientists that the sun revolved around the Earth once per day because that's all they could observe.
What made people change their minds and realize that it was the Earth orbiting around the sun?
They were presented with new evidence in the form of something called stellar parallax.
Whoa, that sounds like a super villain on a sci-fi show.
Yeah, or a bad 90s rock band.
It's actually a very interesting concept. Take one finger and extend it out like this. Now, close one eye and notice where that finger is in relation to the background. Now, this whole time, keep your hand totally still in the same place. Quickly switch eyes. Did you notice that your finger moved in relation to the background? Now switch back and forth between eyes, but don't move your finger. Your finger seems to move side to side, but it's not. Your hand is totally still in the same place. It's an illusion. It's called parallax. And we see that same movement with stars through the Earth's orbit around the sun. Stellar parallax cannot be explained if the sun revolves around the Earth. This is one piece of evidence that caused scientists to revise their ideas. Today, we know that the Earth orbits the sun.
Now that we've explored Earth's orbit and rotation, why don't we take a look at some of the other planets in our solar system?
As we just learned, one orbit of the Earth around the sun takes 1 year, and the spinning takes 1 day, but it's different on other planets. A year on Mercury takes only 87 days, but a year on Jupiter takes 12 years. 1 day on Saturn lasts only 10 and a half hours, but on Venus, it takes 5,000 hours.
To see how its movement affects us every day, let's go to some real-world science. One orbit around the sun isn't exactly 365 days. It's 365 and a quarter days. It's a small difference, but if you don't correct it, the calendar will fall out of sync with the seasons. So in modern times, we add an extra day to the month of February every 4 years to make up for the difference. This is what we call a leap year. A little too accurate if you ask me. This is I have a dentist appointment tomorrow. Ever seen a wall of clocks like this, each with a different time in a different city across the world? These are what we call time zones. Before clocks were invented, people kept time based on the sun's position in the sky. But because of the Earth's rotation, the time was different for each location across the world. What's morning in France is lunchtime in India, and nighttime in Alaska. To make up for these differences, the globe was divided up into time zones that help us account for the movement of the sun's light across the globe. There are 24 different time zones. Each time zone 1 hour different from the next. Here in the U.S., we have 4 time zones: Pacific, Mountain, Central, and Eastern. This is why you can use the argument, hey, but it's dinner time somewhere, when you tell your mom you want pizza for breakfast. Now, let's kick it over to Zoe.
On today's DIY, I'm going to show you how to keep track of time with your very own sundial. To get started, we're going to need a paper plate, a glue stick, a straw, tape, a pair of scissors, a compass, a sundial printout, a sharpened pencil, and of course, a sunny day. First, print out a sundial face that you can access on our website, generationgenius.com. Cut out the sundial face and glue it across your plate. Then, use a pencil to poke a hole through the center of the plate. Then, take your straw, which will be our sundial's gnomon, and stick it through the hole. A gnomon is the part of the sundial that casts a shadow. Next, flip over your paper plate and tape down the other side of the straw. It's almost noon, which means it's time to take our sundial outside. Put the plate on the ground in a sunny spot and tilt the straw just slightly towards the closest pole. That's the North Pole for those in the Northern Hemisphere, and the South Pole for those in the Southern Hemisphere. You can find the nearest pole with the help of any compass, or ask an adult for help. Whatever time it is, rotate the plate until the straw's shadow hits the current time on your sundial face. Right now, how the gnomon shadow falls. You'll notice the shadow moves in a clockwise direction around the sundial as the day goes on. This is caused by the Earth's rotation, which corresponds to the hours of the day. Now you can tell time based on the Earth's rotation. Try it yourself.
Now, let's review. Today, you learned that the Earth rotates on its axis every 24 hours and orbits around the Sun every 365.25 days.
That its orbit around the sun causes some stars to be visible only in certain months.
And its rotation causes observable patterns, like night and day, and stars to move across the sky.
It's crazy to think that the Earth is spinning right now beneath our feet.
And now we know it's all due to science and not groundhogs.
But they look so cute when they wear that top hat.
Join us next time on Labracazam. I'm Dr. Jeff.
I'm Izzy.
I'm Zoe.
I'm Bert.
Remember,
Always question, always wonder.